Pointer is a very fundamental and important concept in programming, but a lot of beginner programmers find it difficult to understand pointers. So in this lesson we will try to demystify pointers, and all you need to know to understand this lesson is how to write a basic C program, how to declare a variable, and how to do simple arithmetic upon those variables. Okay, so let's get started. To understand pointers, we first should understand how various data types or various variables are stored in computer's memory. Okay, so let us say this figure in the right here is computer's memory. And when we talk about computer's memory in context of program execution, we mostly talk about the random access memory or the RAM. We often say that my machine has got 2 GB of 2 gigabytes of RAM or 4 GB of RAM. Now let's say these segments or partitions that we are showing here in the memory is each 1 byte of memory. Now in a typical memory architecture, in a typical computer architecture of the memory, each byte of the memory has an address. So let's say the first byte in this memory, which we can assume to be the lowest byte deep down here, has an address 0, and the address keeps on increasing as we go towards the top. So we go on like 0, 1, 2, and let's assume this particular address is 201. So the next byte would have an address of 202, and we will go on like 203, 204, and so on. Now when we declare a variable in our program, let's say for example if we declare a variable a of type integer, then when this program executes, the computer allocates some amount of memory corresponding to this particular variable. How much memory it allocates depends upon the data type and also upon the compiler. So in a typical modern day compiler, an integer is allocated 4 bytes of memory. Character variable is allocated 1 byte of memory. Float is allocated 4 bytes of memory, and we can have other variables as well. Okay, so as soon as the computer sees a declaration like this during the program's execution, it knows that this is an integer variable, so I need to allocate 4 bytes of memory. Let's say in our example it allocates memory starting address 204 to address 207 for A, and the computer has an internal structure, a lookup table, where it stores this information that there is a variable A, it is of type integer, and it is located at address 204, which is the starting address of the variable. Now if we declare another variable, say for example if we declare a variable named C, which is of type character, now once again when the machine sees this declaration, it knows that it is a character variable, so it needs 1 byte of memory. So it looks for some free space. Let's say in this case it allocates the address 209, the byte 209 for C, and once again it keeps an entry for it in an internal structure called lookup table, that hey, C is a character and its address is 209. Now when we perform some operation with these variables, like let's say if we initialize A to 5, when our machine or computer sees such a statement, it looks into the lookup table for this variable A. So it finds this variable A, that it is an integer and it is at address 204. So it goes at address 204, and in these 4 bytes starting 204, it writes this value 5. Now in reality the value is written in binary, but for the sake of understanding we are writing here in decimal form. Now once again let's say we have some statements, and then again after these statements we have another statement which increments A. Now again when computer sees that A has to be incremented, it again looks for this address for A, goes to the address and modifies this value at this particular address. So this block of memory allocated for A stores the value 6 now. Now all of this is really cool, but can we know the address of a variable in our program, or can we operate upon these memory addresses in our program? Well, yes, you can do so in a C or C++ program using the concept of pointers. Pointers are variables that store the address of another variable. And to make you understand about this a little better, I'll redraw a couple of these things. Let us say we have a block of 4 bytes at address 204 that stores an integer variable a. Now we can have another variable, the type of which is pointer to integer, and let us say the name of this variable is p. Now this variable p can store the address of a, and using the properties of p or using some operators upon p, we can reach a. Now p also takes some memory, so let's say it is stored at location address 64 and it also takes 4 bytes of memory. We can also modify p to point to another integer. So let's say if we have another integer at address 208 named b and having value 10, and if we change the address in p from 204 to 208, then p now points to b. Let us now see the syntax of pointer variables in C. A normal variable is declared by writing the data type and the variable name. So int a means that we have a variable a of type int. If we want to write a pointer variable that should point to another variable, all we do is we put an asterisk sign before the variable. So p is now a pointer variable that points to an integer. So p is a variable that can store the address of an integer. Now to store the address of a in p, we need to use a statement like p is equal to ampersand a. Now if we put ampersand in front of a variable, it gives us the address of that particular variable. In fact, it returns a pointer to that particular variable. Okay, so let's try to see a simulation of this. Let's say when we declared the variable a, then it was allocated an address 204. Now we declare a pointer to integer p. Let's say it was allocated address 64. Now when we write a statement like p is equal to ampersand a, then p now has the address of a and it kind of points to a. Let's initialize a to some value. Let's say a is equal to 5. So we'll fill value 5 into a now. Now what will happen if I print p? What will be the output? Any guesses? Think about it. Okay, so if we try to print p, then the output will be 204 because p has a value 204. What if we simply try to print ampersand of a? Ampersand of a also gives us the address of a, so this will also be 204. What if we want to print ampersand of p? Now p is also a variable and it is also stored in the memory. So ampersand, since it gives you the address of that variable, so printing ampersand of p should give us 64, which is the address of p. Now there is one more important property of pointer. If we put an asterisk sign in front of the pointer, then it gives us the value at the location that it points to. So what will happen if we try to print star of p, asterisk of p? Well, it will give us 5. This concept is called as dereferencing because we have a reference, or we have stored an address in p and we kind of get the value at this particular address using this operator. In fact, we can modify the value at this particular location by saying something like star p is now 8. Star p means value at p, and so the value at p is now modified to 8. So what will happen if you print star p or print a now? The output will be 8. By value of p, I mean value at address p. So p is the address and star p is the value at address that is stored in p. Okay, to just to reiterate, we define a pointer variable by putting an asterisk sign in front of the variable name, and if we put an ampersand sign in front of a variable name, we get the address of it. So if we try to print a pointer variable without asterisk sign or operate upon it without asterisk sign, we are operating with the address. While if we put an asterisk sign in front of the pointer variable and operate upon it, then we are operating the value at that address. So this was some of the basics of pointers. In the coming lessons, we will see some code snippets where we will see some of the common errors that we make while using pointers, and we will also learn pointer arithmetic and pointers in the context of arrays. So thanks for watching.